Yeah, dear students, in this video we will discuss the chapter 9.12 Greens Theorem. So, Greens Theorem in a plane. Suppose that C is piecewise smooth simple closed curve bounding a simply connected region R. P, Q and its partial derivative are continuous in the region. Then we get the following results. First, line integral is equal to double integral. Here on the right hand side, you notice we have seen two terms for conservative vector field P y, which is equal to Q s. Here, if they are equal, this term will be 0, otherwise not. So integral P dx Q dy, if f is pi plus qi, dr is dxi dyj, then this is f dr. This can be calculated by derivative of q with respect to x partially minus derivative of p with respect to y partially. Differentiate dA, and the dA can be dx dy or dy dx depending upon our choice, that whether the double integration over the region, where the region is type 1 region or type 2 region. Okay, and we have seen what is the meaning of smooth curve, simple curve, piecewise smooth, closed curve. All these terms have been analyzed in previous chapters. So now let's go straight away to solve problems. See, here there are two different kinds of problems. First one is to verify Green's theorem. In this case, you have to solve left hand side, find an answer, solve right hand side, find an answer, check whether they are equal. This is the case of verification of Green's theorem. And sometimes you will ask apply Green's theorem, that is, or use Green's theorem. In this case, instead of solving the left hand side, we use only the right hand side. To find the solution for the left hand side, we use the right hand side to solve, only right hand side. Only right hand side will be used, right? So there are two cases, verify Green's theorem or apply Green's theorem. That's what we are going to do. So type 1 region, type 2 region that you studied in calculus 2 should be recalled. When x takes constant limits and y takes variable limits g1x to g2x, and there is a function f of xy, and you want to differentiate with respect to y first and then x. This is called type 1 region. Interaction starts with respect to y first in type 1 region. Obviously type 2 you will get the limits of y will be constant c and d. The limits of x will be h1 of y to h2 of y, and the function f of x y can be derived first with respect to x, then with respect to y. This is type 2 region. You should remember this one that we have studied in calculus 2 to evaluate the right hand side where there is a double integral. Now let's verify Green's theorem by evaluating both the integrals. Okay, they have given to both the terms. This is the left hand side is equal to right hand side. Left hand side is the p dx q dy. Right hand side, this should have been, you should check, this is what, qx minus py. Is it qx minus py? Will verify and then you will apply Green's theorem, right? Here that should be equality. Here this is the left hand side, this is p dx q dy, and this should have been qx minus py. We will check, and dA can be our choice of either type 1 or type 2 region, right? Okay, let's go ahead with the problem number 1. What is p? P is x minus y. Therefore, py or px or py. We want py. Py is negative 1. What is q? Q is xy, and qx is equal to y. We don't want to verify whether they are equal or not. There is no question about conservative. If they are equal, the integration right hand side will be 0. and that left hand side also will be 0, so you get it conservative. That is different. So what find the as per the Greens theorem, right hand side should be this one. Where is it? Qx minus py, isn't it? So we will find Qx minus py. Qx is y minus of minus 1, so this is y plus 1. So what's given on the right side is Qx minus py, isn't it? So straight away we have to start integration. So what is the left hand side? You see the C is a triangle with vertices. So there are three curves. Triangle with vertices. What are the vertices? First vertex is 0, 0. This is x-axis and this is y-axis. Second vertex is 1, 0. So this line, this C1 is on the x-axis. Second 1, 0 to 1, 3. So this is 1, 2, 3. Assume that you are here. 3. This is curve C2. This point is 1, 3, and then 1, 3 to this one. You are moving back. This is C3. So there are three simple smooth curves, isn't it? They are together closed curve, right? Okay. In this case, to find the left hand side, this integration, we need to evaluate the integration over three curves, C1, C2 and C3. Okay, we'll do it. Along C1 is x-axis, right? So y is 0 and of course dy is also 0. X varies from 0 to 1. So substitute all this in the first left hand side. Integral x varies from 0 to 1, x minus y is 0 dx plus dy and y is 0, second term is obviously 0. So this is x square over 2 from 0 to 1, the answer is 1 over 2. Next, along C2, what is happening in this curve? X is fixed, x is 1, this gives dx is 0 and y varies from 0 to 3. So apply the left hand side. So first answer the left hand side along C1 curve is half. Along C2, integral over C2 is integral 0 to 3 for y. Dx is 0, the first term will be 0 plus x into y. X is 1, y is variable. Y dy. Answer is y square over 2 from 0 to 3, so 9 over 2. Along C2 we found 9 over 2. For now third, along C3, what is given? Okay, you have to find the curve, the equation of the line joining the points 0, 0 and so first answer is half, second answer is 9 over 2. You remember this one. Now we will do for C3. The equation line joining 0, 0 to 1, 3. Will you find the line equation? The slope is 3 and the constant is 0. Okay, it's okay. You can use this formula. Y, this is x0, y0. This is x1, y1, isn't it? Use the formula y minus y1 divided by y1 minus y0, which is x minus x1 divided by x1 minus x0. What is y minus y1? Y is variable, y1 is 3 divided by y1, 3 minus 0 is 3. 3 3 minus y0 is 0 is equal to x. X is x minus x1 is 1 divided by x1 minus 1 minus 0 is 1. So now simplify this one. Take 3 to the right side, plus multiply 3x minus 3. So y is equal to, I am writing here, y is equal to 3x. When you simplify this term, this equation, you will get y is equal to 3x is the line. This line is called y is equal to 3x. So along C3 is nothing but y is equal to 3x. Okay, I will erase this one. So along C3, so y is equal to 3x, therefore dy is equal to 3 times dx. Therefore integral over C3 is equal to y varies, x varies in this interval. You notice that x varies from 1 to 0. X is 1 and y x. See this triangle, you might have noticed this point is 1 comma 3 and 0 comma 0. So when everything in x is starting from 1 and ending to 0, 1 to 0. First term is x minus y is 3x dx plus x into y, x into 3x dx. So simplify it. X minus 3x is minus 2x plus this is 3 times dx, so 9x squared dx. There will 1 to 0. So minus 2x square over 2 plus 9x cube over 3 and 1 to 0. But you get here is 0 is our upper limit, minus when you substitute 2 x lower limit is 1 minus 1 plus 3. It will be positive 2 and multiply outside negative, it will be negative 2. So 3 integrals. Integral left hand side, first answer is half, second answer is 9 over 2, third is negative 2. So the first two terms will give 9 plus 1, 10 over 2, 5 minus 2, this is 3. So left hand side answer is 3. Now we got to verify the right hand side alone, only the right hand side this time. And we have verified actually. We have verified this one is q x minus py. Now let's do the right hand side. And remember the same triangle 0 0 1 0 1 3, isn't it? This is y-axis and this is x-axis. Now if you want to type 1 region, you take a vertical strip. The vertical strip starts from here y value is 0, ends at here y value, we know this line is y is equal to 3x, so ends at 3x. So y limit is 0 to 3x, here starts, here ends, isn't it? And x should move from here to here, so x is from 0 to 1. So right hand side double integral over r can be written as double integral x from 0 to 1, y is from 0 to 3x, and y plus 1 dA as a type 1 region we are considering, type 1 region. So dy dx, so the limit of y will be variable, the limit of x will be constant from this graph. Integrate it with respect to y, integrate and substitute upper and lower limits. Integral 0 to 1 outer limit, inner limit is y square over 2 plus y from 0 to 3x and dx. Integral 0 to 1 3x 9x square over 2 plus 3x dx. Integrate with respect to x again. 9x cube over 6 plus 3x square over 2 from 0 to 1. So this is 9 over 6 plus 3 over 2. Now you get 9 over 6 plus 3 over 2. You can take LCM as 12, 18 plus 18, 36 over 12. This is 3. So right hand side is also 3. Left hand side we have already seen, right? So left hand side is equal to right hand side. The Greens theorem has been verified for problem number 1. Let's do it for second problem. Okay, let's continue with the problem 3. The second problem is problem 3, and here p is negative y square and q is x square. So py is equal to negative 2y and qx is equal to 2x. Obviously qx minus py will be 2x, minus of minus 2y will be plus 2y, which is given here. So this problem deals with again Greens theorem, isn't it? Left hand side is single integral over c over the single curve. X is equal to 3t and y is equal to 3. X is equal to 3 cosine t and y is equal to 3 sine t, which represents a circle, and the angle is 0 to 2 pi. So full circle, not a semicircular first column. It's a full circle, isn't it? So we are given x is equal to 3t. Differentiate x. What do you get? dx. X is equal to 3t, 3 cosine t. Differentiate it with respect to t. 3. When you differentiate cosine, it will be negative sine t and dt. Therefore, what is dy from the definition of y? Y is equal to 3 sine t. 3 cosine t dt. Okay, we need this information, right? Because the left hand side and right hand side, we are converting everything into parametric form. So left hand side is integral over the curve c, which is integral over t. See, with respect to t, we are going to do 0 to 2 pi. And what is y? Integration, first integration. Y square. Y is 3 sine t. So 9 sine square t. And dx is given here, minus 3 sine t dt. That is the first term. Second term, x square. X square is 9 cosine square t and dx, dy, 3 cosine t dt. Now we have to simplify and integrate it. Okay. Okay, simplify. Let's simplify this further. What's the next step? Let me solve this on another white page. You remember this first row, 9 sine square minus 3 sine t dt plus, I will repeat it. Okay, then we will take a white sheet. Fine. I will repeat it. In the left hand side integration, LHS is integral over c, which is integral 0 to 2 pi negative 9 sine square t and negative 3 sine t dt. Second term, integral 0 to 2 pi. You can separate or you can write under one integration. There is no problem. Under one integration is possible. So plus 9 cosine square t and 3 cosine t dt. Here the integration ends. So we further simplify into this will be 9 into minus 9 into minus 327. Here 9 into 327. 27 is common constant. Keep it outside. Now integral 0 to 2 pi. First term will be sin square t sin cube t. We can write it as sin cube t. We can write it as 1 minus cosine square t into sin t dt, the first time. This sin square has been written as 1 minus cosine square. This sin t is repeated here. Similarly, 9 into 3 has gone from the second term. Cosine square 1 minus sin square t and then cosine t dt. This will make the integration easier. We know how to integrate the sine powers and cosine powers, or the combination of these two. You have seen it in calculus 2. Refer this if you want. Okay. Now 27, this one is going to be separated integral 0 to 2 pi. First one, sin t minus cosine square t sin t dt. Dt is common. You can take one term. Dt is common, so take it here. We don't want dt here, that's right. Plus cosine t minus sin square t cosine t. What is happening here? What is happening here? We are multiplying this sin t to every term, and here cosine t to every term. That is what in the second step, the next step, right? Okay. Now, how to integrate term by term? Integration of sin t square is negative cosine t. Integration of cosine t is it will be sin t. Now we have to be careful in integrating combination of cosine and sine. See the highest degree in cosine for the first term. So take u is equal to cosine t here. For the second term here u is equal to sin t. And so substitution method, separately integrate them if you like. That will give you an existence. 27, integral 0 to 2 pi sin t dt, first one, minus integral 0 to 2 pi cosine square t sin t dt, third term, integral cosine t dt 0 to 2 pi, finally minus integral 0 to 2 pi sin square t cosine t dt. There are 4 integrations to be done. Here, straight away the answer will be coming in the first and third term. First and second term, let u is equal to cosine t. The last term, let u is equal to sin t. So what happens further? When u, case 1, when u is cosine t, du will be minus sin t dt. In case 2, if u is sin t, then du will be cosine t dt. Okay. Fine. Let's go back and check integrations. Okay. Now this will be u square, isn't it? Minus this will be clubbing with the sin, minus sin t dt will be du. So it will be positive, the first two terms. Okay. Therefore, the left hand side LHS goes like this. Integral, first integration will be giving you, so 27 is a constant outside. First integration of sin t, is sin t, will be giving you minus cosine t 0 to 2 pi. Second integration, the negative goes inside because you know negative sin t dt is du. So this negative and this sin t will be du. So this is u square du. Integration will be u cube over 3. It is u cube over 3. What is u? U is cosine. I will write in the next step. Next step, what is it? Integration of cosine t is Sin t, there is no change, isn't it? So this will be sin t from 0 to 2 pi. Finally, is it minus this will be u square, this will be du. So negative u square du, where negative is outside. So integration will be u cube over 3 with negative is outside. That's it. Now substitute upper and lower limit. 27 is outside. Minus cosine 2 pi is minus is outside. Cosine 2 pi is cosine 0 is 1 minus cosine 0 is 1. 1 minus 1 0. First term becomes 0. Second term u cube by u cube is cosine t or cosine cube t over 3 from 0 to 2 pi. We'll do it next step. Here sine 2 pi minus 0 minus 0. Finally here u is sine cube t divided by 3 is 0 to 2 pi. And this sine is 0 because 2 pi and 0 both points sine will be there. The last time will be also 0. Let's check only the second point. 0 plus cosine, so 1 by 3 is common. Cosine 2 pi is 0, 1 minus 1 is 0. 1 minus 1, 0, again 0, 0. All the terms are 0, the answer is 0. The left hand side is 0. Let's think of the right hand side. What is the right hand side? Here, double integral over the region R qx minus py dA, isn't it? Let's convert everything into parametric form because it is a parametric form. Given x is equal to 3 cosine t, y is equal to 3 sin t. When it is in polar form, actually dA can be dx dy or dy dx. It doesn't matter. It will be r dr d theta, isn't it? And you should remember this is not theta, it is tt, t, dr dt. R is given, the limit of r and t, everything is given. Limit of r is 0 to 3 because x is equal to r cosine theta, isn't it? Limit of theta is t is 0 to 0 less than or t less than 2 pi. So here we go. What do you get? 2x qx minus py. Qx minus py is equal to 2x plus 2y. Now the right hand side becomes double integral 2x. What is 2 into so we gotta take this one is x is equal to r cosine theta. Take r cosine theta in parametric form. R sine, the limit of r is 0 to 3, will do it. And this little bit theta, and theta is between 0 and 2 pi. What happens here? We keep this r as it is in parametric form, and then we substitute the limit of r. R is 0 to 3. Okay. Okay. Now we write the parametric form of the circle x equal to r cosine theta, the polar form. We are converting this into polar form. Now you write x is equal to r cosine theta, which is r cosine theta plus r sin theta, because 2 is been taken as common, and dA. 2 is outside. First limit r, first integration is outside, integration is r and theta 0 to 2 pi. Inner integration will be r 0 to 3. R cosine theta, r sin theta, and dx by is r dr d theta, isn't it? Now r can be taken common. Joining with this r will be r square. It will be 2r. Okay. 0 to 2 pi integral 0 to 3 cosine theta plus sin theta. R is outside. Now r square dr d theta. Now they can be integrated in iterative, or so integrate r with respect to r, you get r cube by 3. And then substitute the upper and lower limit for r. That will be done in the next step, which is equal to 2 integral 0 to 2 pi r square has been divided. It will be r cube over 3 from 0 to 3. Remaining terms are cosine theta plus sine theta d theta. So when you integrate this, so substitute upper and lower limit. 1 by 3 is constant, keep it outside. 2 over 3. So upper limit is 3. 3 cube is 27. 3 cube is 27 minus 0. So there will be 27 as a constant and 0 to 2 pi cosine theta and sine theta d theta. So 3 can be cancelled with 27. It will be 9. 9 into 2, 18 is the constant outside. When you integrate cosine theta, you will get sine theta. When you integrate sine theta, you will get minus cosine theta. Now use the upper and lower limit. 18 sine 2 pi is 0 minus cosine 2 pi is 1 minus 1 minus sine 0 is 0 minus cosine 0 is minus 1. So this is minus 1, this will be minus and minus positive 1 will be 0. So the answer is 0. Hence right hand side is 0, which is equal to left hand side. The Greens theorem has been verified. Let's go to the next problem. Use Greens theorem. Now you have to, when you get to use Greens theorem, instead of evaluating the left hand side, we are going to use the right hand side one integration, because the left hand side, you see, it's a rectangle. There will be 4 different curves to integrate. C1, C2, C3 and C4. You can find the rectangles. So first line, second line, third line and first last 2 ones. So this is possible. This is possible to be easily solved by using Greens theorem, which states that integral p dx q dy, the left side, is equal to double integral qx minus py, isn't it? You have to find dx dy or dy dx and the limits over the region. So right hand side we have to find. That's it. Problem number 8 we are going to solve here. Problem number 8. P is equal to x minus 3y. So py is equal to minus 3. What is q? Q is equal to 4x plus y. Qx is equal to 4. So qx minus py is equal to 4 minus of minus 3, which is 7. Are we on the right track? 7. Now the question is, this part has been clear. We are using Greens theorem, so only right hand side should be used. Qx minus py is 7. So double integral 7 dx dy. You consider the region as type 1 region. I write the type 1 region here. It is x-axis here, y-axis here, isn't it? X from minus 2 to 0. Sorry, x minus 2 comma 0. This is minus 2 comma 0. Here 3 comma 0. This is the first line C1, isn't it? And 3 comma 0 to 1 to this point 3 comma 2, second curve C2, and now 3 comma 2 to minus 2 comma 2, minus 2 comma 2. From minus, this is C3, and minus 2 to 2 comma 2 to minus 2 comma 0, which is C4. And we take this rectangle, all limits are constant. When there is a rectangle, when you integrate over a rectangle, all the limits will be constant. So x is this direction, minus 2 to 3, and y is in this direction, 0 to 2, isn't it? That is what we are going to do. So when all the limits are constant, the order can be dx dy or dy dx. It doesn't matter, isn't it? So now what we are doing, right hand side is double integral px minus qx minus py, which is 7. I take dx dy, always type 1 region unless otherwise specified. So x, the limit of x is from minus 2 to 3, and limit of y is from 0 to 2. Now 7 is constant. Keep the 7 outside, integrate it. We will erase some part and we will continue to integrate. This part is not necessary now. Okay, that continues here. Integral 7 is outside. Integral x will be x, dx will be x values minus 2 to 3. Integral dy will be y, its limit will be 0 to 2. Now which is 7, 3 plus 2 is 5 into 2, 10 into 7, 70. The answer is 70. That's right. Problem number 8 has been solved. Problem number 10. This is P and this is Q. C is the ellipse 9 times x minus 1 whole square, 4 times x y minus 3 whole square. So only one circle on the left hand side, ellipse in the left hand side. In the right hand side, one region. We will see. First, let's take problem number 10. What is P? E raised to 2x sine 2y. Q, e raised to x cosine 2y. We find Py. Integrate with respect to y. Only this e power 2x will be remaining constant. When you differentiate sine 2y, you get cosine 2y. And now differentiate q with respect to x. This will remain as it is, cosine 2y. If e power 2x again, okay. Now when you remember, when you differentiate cosine 2y, you will end up with a 2, a constant. Here qx is e raised to 2x and another 2. So both are looking same. E raised to 2x, e raised to 2x, cosine 2y, 2. So Py is equal to qx. Obviously, what happens? The right hand side, which is double integral qx minus py dA, will be 0 because they are equal. When they are equal, qx minus py is 0. So second problem, the answer is 0, very easy, because the derivatives are py is equal to qx. So this field is conservative vector field. When it is a conservative vector field over a closed circuit or closed curve, the integration will be 0. Problem number 14 is to be solved now. Yes, sir, problem number 14. White sheet, separate sheet, we will solve it. Let's get the terms in order. This is y is equal to x square, this is y is equal to x cube. So the graphs, the area C is the boundary of the region in the first quadrant determined by the graphs y is equal to x square and y is equal to x cube. it will be looking like this: x-axis, y-axis. Y is equal to x square, y is equal to x square. And what about y is equal to x cube? It will be above or below? It will be going like this, isn't it? Y is equal to x cube. So this is the area on which we are integrating. So when you take type 1 error, type 1 region, you take a vertical strip. Integrate with respect to y first. See, lower limit is this one, upper limit is this one for y. And where they intersect this point, so distance is this distance is x-axis. Let's find where they intersect. Okay, because we need only double integration, we don't need to use single integration. We are using the Greens Theorem. Take this is your p. P is xy square, py is 2xy, and q is this one, 3 cosine y. Qx is 0. Therefore qx minus py is equal to 0 minus 2xy, which is minus 2xy. Now we got the term to integrate. We have to write dA. dA is dx dy, or dy dx. We will take it the first type, type 1 region, dy dx, where y varies from x cube to x square. Now when they meet at, so when both the curves meet at the point x square is equal to x cube, which gives x cube minus x square is 0. Take x square common, x square into x minus 1 is 0. So x is 0, x is 0 and x is 1. These are the two meeting points. X values are 0 and 1. 0 here, they meet at here, and they meet at here, isn't it? So x value, so double integration, x limit is 0 to 1 for y limit x cube to x square minus 2xy dy dx. Now you can integrate this one, I think. Integrate in the substitute upper limit. Let me do it. White sheet. What is it? Now the right hand side is minus double integral 2xy. I have taken the minus from outside, from 2xy outside, dy dx. The limit of y is from x cube to x square. This is 0 to 1 for x. Now integrate y with respect to y. You will get minus 2x y square over 2 from x cube to x square. Another integration is with respect to x, writing outside. So 2 and 2 will be cancelled. You get minus integral 0 to 1 x into upper limit x square. Instead of y, replace x square. It will be x power 4 minus x. Y will be replaced by x cube. X cube square will be x power 6. Yes, x power 6. Now the outside x should be multiplied inside. You get minus integral 0 to 1 x power 5 minus x power 7 dx. So what's next? Therefore integration will give you minus x power 6 over 6 minus x power 8 over 8 from 0 to 1. Now substitute upper and lower limit. Upper limit is 1. So minus 1, you substitute 1 over 6. Another term will get 1 over 8. Simplify this one. You get 8 minus 6 over 48, which is minus 2 over 48. So it will be minus 1 over 24. slightly different from the book answer, isn't it? Do not worry about the book answer. This is the right answer. Thank you. And the next chapter will be discussed in the next video. The next chapter will be different. So face interval, we will discuss this chapter in the next video. Thank you very much.